enerji binalar forumu kapsamında sıfır enerji binalar.
I would like to welcome you all to the session Zero Energy Building and Passive System Solutions. First and foremost, I'd like to introduce myself. I'm from Akdeniz University, Faculty of Architecture. I'm in the Internal Architecture department. We have 4 prominent speakers who are the representatives of the sector. Then there will be a questions and answers session. The first presentation will be by Aylin, Kalav, DörkenSistem TechnicalMarketingExecutive. She's going to talk about healthy building design considering the climate change reality. Before that, I'd like to introduce her to you. Aylin is a physicist, graduate of hydropolitics, English literature, and the graduate of, she has such a master's degree program, and in the concrete sector and cement sector, she's worked a lot, and in the last 12 years, she is a technical marketing executive of DörkenSistem for the last 12 years. And in construction sector, she just passed her 20 years, and now, if you share her presentation, we will continue. Thank you very much, Aylin. You can turn on your microphone. Thank you, Shadna. I've been involved in this sector for 25 years, and Durkan is a good system. So I wasn't here with this task, but I took this task in a very brief moment. I am addressing you from our plant from the place of production, and it is in spirit of this. And I am very honored. We are very honored to be part of it, part of Zero Build Turkey, especially as we are working on a passive house, greenhouse, zero energy buildings, because we are providing the materials for this. Platforms are very important to us. So I'd like to thank everyone who contributed to the organization. In my presentation, I'll give you a summary because Durkan is about, it is dealing with everything related to a building envelope, from the sub-foundation to the roof, the wind impermeability, and also the insulation and insulation protection. Especially there is a tightness should be involved in this as well. Let's continue with my presentation. Of course, in the changing climate reality, I am highlighting this because with the climate changes and the decreasing resources, and of course using them efficiently, and with that also the precipitation rain is precipitation is very high, and that poses some necessities to be formed. So the insulation techniques and air tightness and the other neglected issues should be addressed with a more serious perspective. When we say building envelope design, there's a skeleton of the building. You saw there could be a light or heavy structure. We have the skeleton. And then it's like a layer which does not permit the air and water, and this could be our skin. And also there is a big external coating. It's like we are wearing a cloth. And of course, the clothes are not for protection of the air conditions, as the Durkan. I will talk about the systems. And within that system, of course, we can see the importance of this. And the loads there are important, and there needs to be a balanced layer structure. We can continue with the presentation. as a most important layer, we can talk of the ones there needs to be the high heat resistance, and also there should be low heat transfer. We have to increase the thicknesses. Regulations should be adopted accordingly. What we know from the system is the high heat resistance and low heat transfer coefficient. So we should not go into the materials only, and we have to look at the column, the junctions, and other materials, and the empty air spaces should be taken into account. If you look at the U value or R value, so we cannot see the real performance of this, and there are other points like the corners, or there is a columns and junctions and other areas. All these are within the risky points, and we have to look at the insulation accordingly. And there is the heated air from there, and we have to be quick there, and there is the air coming from there, the hot weather coming from this. So I'm going to other sections, I will increase. There needs to be, if you have a good insulation thickness, and if you think of all of this, the risk is then taken. The structure is not only about the material, but at the same time, it's about the movement of humidity and air. So with the possible, with the controlling of this, you make that the system is there, and of course, you then decrease the system. It's related to the system structure. I'd like to give you some information about condensation. In few slides, I'll look at this. And of course, there are in some weak points. We see what is there, so we can see. Let's continue. Therefore, there are three important things: be it vapor diffusion, air tightness, and wind tightness. At this very point, when we take all the necessary measures, we can talk about the good climate there, and of course, it's about a zero energy structure. Within this system, most important thing is the diffusion. It is about the carrying of the water evaporation without air movement, and there are the differences there. At this stage, it's about there needs to be the related ST value, and I will tell you what ST value is in the upcoming slides. So the problem is that, let's continue. Most important problem is about them, and of course, if the relative is a 50%, and we can say that. We can say that there is 962 Pascal as difference. Able to will expand, and it will go to the address of the construction. At this very stage, with the evaporation, of course, we will look at the heat insulation. and it will go from that direction. Let's continue. During that stage, the heat insulation, as the insulation will be colder, we will see the evaporation will be there and the condensation take place. As you see here, the insulation, and it is with air tightness and with tight insulation. So condensation will be within the heat structure. And let's continue. Let's continue. Faster. Can you go back? In one square cube, in one cubic meter, there is one a certain there's a 25 centigrades of cooling. It will be more than 14 grams, and the people generally they say that when the roof is leaking, they think that the only problem is about this one. It's about the systems as well, because the condensation water can harm the structure, and there will be fungi and other formations can be there. Let's continue. Let's continue. In the areas of residential areas, there is a 15 liter of evaporation formation. When you have this, there is a certain evacuation of the water, and this can go up. So, of course, when you look at this, it is very important from the water evaporation. When you make it airtight, you have to plan the ventilation there. Let's continue a bit faster. So, in this, there is such a thing is continue with the system. Important thing is that it's the SD value of the materials. It is when we say these ones, as we can see, is about the water evaporation diffusion equivalent of air layer thickness. So if there's a mineral pool, its new value is a 1. When you get the thickness as 10, when you multiply this in meters, we say 10 centimeter of this. So this is quite important. Let's continue. This is indeed important because until 2018, what is the SD value is that until 0.5 meters evaporation layer, and between 0.5 to 1,500 evaporation control layers, and if it is bit above 1,500, it is the evaporation cutting system. In 2018, these are changed, as you can see in the graph. We are talking about 100 and 150 meters. And after 150 meters, in terms of SD value or the conductivity of evaporation, it is different. So if it is 100,000% of a material and between 4,000 material layer, there's only 3 meters of evaporation, and this could be also taken. So it's turned into diffusion preventive one, and if it is a 1,150, it is cutting strategies, ST values are important because the air tightness or air impermeability is always achieved by this in the hot part of the layer. It should be taken for the ST value. And of course, it's on a unit weight in the market, but the most important thing is that the ST values, I mean, the diffusion resistances are the most important thing here. Let's continue. This is very detailed. It's a detail. For example, there's laser condensation table. I advise you that. So in the calculation, this condensation is very important. You see where you are there with a good system or not, with the good values or not. And let's continue. Of course, in our products, we are talking about air permeable layers, and as we produce all of these with them, we have the simulations regarding them. We make all the simulations, and with that, we can make a suggestion of this. And air impermeability is related to material, and also it's about the hot part of the building. And there are many losses through air. This is about the suture or joint points of this, and there is the air getting high, and of course instead of this there will be cold water, and this is important there. And of course it is important that the impermeability and the ST values are very important. While you are having this, while making the planning, this system is in 1,400. It is about, it shows the comparison there, and there is it gives the condensation heat temperature, and it is 4,408. 4,108. And the most important thing here is about the layer. It is about the impermeability is important. In the US, there is global door system, and in Zero Builds, the previous sessions, it was discussed, so I will just skip it. But it's about where the building loses energy. You can just test them, and the barriers and evaporation and air barriers are there. It is only one material. There are different constructions and different structures, and based on the different needs, there are different ST values. Let's continue. Let's continue. Skip this part. When we say width impermeability, the layer changes, and what we need is the evaporation permeable material. For this layer, it's always in the cold part of the building. This effect, you can go a bit faster. So we should have been faster, but of course it is about. Let's continue. It is about the airtight layer is cold, and so the condensation between the internal wall and the outer insulation. The most important thing is that from a very small joint, when there is air there, you lose 90% of the performance. There is membranes, the evaporation permeable ones, and of course, and the barriers are important, and we provide them. Let's continue. I told you we are making simulations, and we provide services, consultancy for our own services. Let's go quicker. And as you can see, of course, there are dry wall systems and the mechanical facets and integrated facets can give different information. And we can look at this. Let's continue. Of course, these are important about the form of the structure. And the implementation is very important here. Yes, we can look, we say that it's important in terms of distribution. Can you please wrap up? This is a very nice presentation, but the implementation matters. And there need to be the right permeability materials. Can we go quickly? What is needed here is this system and the cartridge systems for the layers. It will be appropriate. It will be appropriate for the material, and you have to select the materials. I was going to talk about the green roof, and I think that it has a longer history than I thought. And there are examples from 1970. Can you go faster with the presentation? This please last words. I will have some questions that I will ask you. Maybe you can then share the information with us. This has been a very important presentation. I mean, it's not possible to have a building envelope in 15 minutes. You have provided us very good information, water, wind, and also once, and you provided very good information with us. And thank you for that. Now I give Prof. Deceuninck Turkey R&D Director, Miss Didem Kale. Kale is working in the zero energy buildings, and she's going to deliver her presentation. Yes, so I'd like to introduce her. She graduated from the Department of Chemistry at TurkeyEge University in 1992. She had her master's degree in the same department, and she is Katip Çelebi University. She is working in the material engineering. She's studying material engineering in her PhD. She started in her career, and she continued as the R&D and product developer as a Deceuninck Turkey for Turkey and others. She will talk about the design, and with the 2003, there's innovative projects. She's responsible for innovative projects, and accepted for this. Before she starts her presentation, it's about taking the component certificate, and I'll share an important success with us, and Didem is going to share this with you, I believe. Higher one, once again. Thank you very much for having such an organization in this platform, for inviting me. I'd like to thank you for the invitation first and foremost. Today, I'll talk about zero build concept. To share my screen, can you see my screen right now? Not right now, but now. So you can you make it full screen? Is it full screen right now? talk about the PVC doors and windows today in zero energy buildings. I'll talk about the PVC window in the passive building. I'll talk about the necessities there. First and foremost, with our company, there are some organizations, and of course, Deceuninck is in the second way in production of PVC. It was established in 1937. It's been the sector in 83 years, and it's present in 91 markets of the world. And we have plants in production plants in 14 different countries. And this is not only about the other countries, and we have some other companies. We have Agapan, Deceuninck, Insa, Pimapan, Maestro, and in aluminum stamp, the aluminum systems, and of course with the R&D system in the emerging markets, we have all the product development processes. I skip this. We have one production plant in İzmir, Menemen, in Kocaeli, Kartepe. And you can see in this slide, and there is the Deceuninck system. With you, I'll talk about the Menemen company as we have. It is not only about it's about PVC production, and we can say that this is the largest production plant, manufacturing plant in Europe. I'll talk about the system. We are here with the system, and we are PVC profile manufacturing with the cassettes. It's taken to this one to the manufacturers, and of course our object it then goes to the final producers. And of course, when we look at this in different parameters, we have several things, and we can say that it is there, and this is an important factor. And of course, in such a way, it's about the heat insulation. As you know, we are talking about the thermal camera, and when we look at this, of course, we can say that there's leakages in the windows. However, when the right window is selected, the heat insulation can be made in the right manner possible. So here, we need to have the airtight windows, and how to look at this. How should we have the right window selection? We have to look at the components. And here there's PVC profile, and we see the screws there. If we are to talk about our expectations from window, not only heat insulation, but for the wind load, there are static expectations as well. And when you think of this, it should be strengthened with the steel. And the mechanical information should be selected. You see a glass implementation application there, the platform sizes, and the values are very important for us. We have to talk about the expectations of thermal performance, acoustic performance, static resistance, and also water and air impermeability, recycling, high quality, and in harmony with the standards, because you provide the services for the countries, so it's important. And there's the CE mark, and the performance criteria statement is important, the sustainability, and there are other parts, other options are there. So in air tightness, instead of its past or its state, we can say that air tightness or air impermeability is, this one is a class 4, the other is the least highest is class 1. So there is with the pressure and precipitation, there is a performance test for water impermeability, and it's about like getting a shoulder. So you look at the climatization.
So all these standards need to define the issue. As regards to the heat insulation, when we look at the development since the 50s, we see that there was only one glass. Now it is two glasses, and then there were two frames, and in principle it is the same. And following the two glasses increased the insulation, and introduction of the new materials improved the situation. Here you see the Atatürk house in Samsun. I took that picture by myself. It is still, in fact, an example that we can see in different parts of Anatolia. There are two frameworks. There are two frames in the same door. Of course, as a result of the development in technology, now we have this thermal transmission can be analyzed by software programs, and we can calculate these thermal values while we are designing the product. But here, I would like to share that these, when we talk about transmissibility, we have frame and also the glass, which can transmit the heat, because these, when these two features are combined, then we have the right and appropriate material. Okay, when we look at these values, this is the common Windows systems in Turkey. It is 60 millimeter, 70 millimeter, and this is the frame thickness. It was 1.5 to 1.3, 1.4. But as for the new generation systems, we have thickness which is smaller than, thinner than 1. It is 0.92 or 0.90. And we have this UF value, which is the 1. What square meter, and the size of the frame is 67 millimeter. We have two systems, and to prevent the leakage, we use certain seals and gaskets. Of course, we have some metal layers to support the system. And while we see that there is a change in this UF value, we have seen there are some parts you see here and how it has changed in the Windows systems. Thanks to the introduction of the glass and also these Windows systems, the values were 2.6, and these value decreased to lesser than 1 point, and we have the most common Windows system here. And when we look at the new generation PVC Windows, we have this UF value is smaller than 1 point, and U is 0.8. That's what we expect. And when we look at the new generation PVC Windows, and I mentioned 3 systems, we have the Legend, and in Wins it is Agapan, and in Winsa it is Revotech, it is Pimapen, it is Nirvana, it is 80 millimeter, and they meet these requirements. But the key point is the passive house component. And when we look at the criteria that are required for passive house Windows systems, these windows and also doors are important, and the exterior doors, of course, and they need to meet the requirements. When we look at the overall situation across the world, you can see the climate zones. It is Arctic, cold, cool, warm, temperate, warm, hot, very hot. So we have 7 different categories and we have climate zones. What we see, it is U window and UF values change according to the climate zones, and you need to meet the requirements of the climate that you are working. Let me skip this part. We, as the firm, we have premium series and we have set our objectives. And the first system is Revotech for Winsa. It is good news for us as well. And we have obtained the Passive House Component Certificate. That means the certificate can be used for Passive House applications. Of course, I am not going to share the details of the components. What we can do, if you want, I really wonder this topic. So if you want, in the QA session, I will ask you some questions to you about this, and then you will elaborate this part. So let me skip some parts. This Revotech, we have certified this, and as for the legend for the Egepen Deceuninck, we have certified this. And as for the second step, and which we will work very hard, and Nirvana for Pimapen and also Legend for Egepen, the second phase will be ready very soon. And cool condition, as I discussed before, there are different expectations and we are working on it and we will make it ready very soon. These cool climate conditions are important for our certification and we are working very hard to make it ready. Of course, there are some standards and requirements for the air tightness in our system, and we are working in this issue. In summary, yes, we have obtained the certification, but the question might be about the cost. What I can say, it is 24mm glass, 70mm PVC system, if we have this. And if we look at the values, and if we assume that it is 17.3 square meter, and the cost difference is not, difference is not so high. It is only 25–30%. So you can compare it with the existing systems. We publish the energy calculations as regards to all the models that we manufacture, and you can select all these new Windows systems and you can compare it in years. So you can select the parts, so you can calculate the issue. My final point is, of course, we talked about we need to have the document that approves that this staff is skillful and this staff is qualified. Let me skip this part. That's it from my side. Thank you. Thanks a lot. In fact, it's a very useful and extremely helpful presentation. It is great to know that you have obtained the certificate. As I said, I will ask a question about this issue in the Q&A session. Yes, another representative from the sector, from Şişecam, and she is the manager of franchise product, Esra Hanım. She will talk about the role of glasses in nearly zero energy buildings. She is a graduate of Department of Architecture. In 1994, she worked. After graduating from the METU Department of Architecture in 1992, Esra Tombak worked as an office and construction site architect in the private sector, started to work as an architect in the Ministry of Public Works and Settlement and also in the Department of Architectural Department in 1997. She has done project preparations and projects provision for administrative structures such as government house, courthouse, prison, ministry buildings. She worked as a branch manager in the Department of Energy Efficiency, which was established in 2009 to regulate and enforce the secondary legislation within the scope of energy efficiency law. And she has been working for this system. Can you see my screen? I can't see your screen. Yes, we can see it. Can you help me to move next slide? So it's not me who's sharing the screen, right? Yeah, our technical team is sharing your presentation. So just please instruct my colleague to go to next slide when you need it. You kindly introduce me. Let me introduce my company. It was established in 1935, and we have been working in this sector for 86 years. And next slide, please. Şişecam has an experience of 86 years, and we manufacture steel, glass package, automotive glasses, and also glass, wool, and recycling. We have facilities in 14 countries, and we export our manufacturers to more than 150 countries. We are the global company, and we are proud of it. I am working in the department, the steel glass. We export products to Russia, to Egypt, and we have manufacturing facilities in 6 countries. We have 10 facilities, and we usually work architectural glasses and also glasses for white appliances and also energy glasses. And we have Care Connects, and we have this white, reinforce, protect, reinforce, and also respect. These are our values, and we have diversity and also inclusivity principle in all parts. And we aim to have operations that do not have negative impact on climate change. Of course, energy is consumed in buildings, and 60% of this energy is used for lighting and also protection in buildings. Next slide. So, and then 40% of the energy consumption is in buildings, and 60% of this 40% is for heating, cooling, lighting, and ventilation. And we have transparent facades for us, as Didem stated. In order to talk about good insulation, we need to choose right materials and the appropriate materials. And the glass has a role in this issue. The heat energy that we are unable to get because of the glass, because of the windows, we make energy consumption and we spend money. So we have this type of issue, and it's same for the summer period when the cooling is needed and there is a demand for cooling. So we have new generation glasses that saves energy. Next slide. First of all, let me talk about glass part. And in the EU, if the right glass is selected by 2030, 75.5 million tons will be saved, and there will be 30% energy consumption, less energy consumption. And the EU construction sector produces CO2, and it is 72%. According to the GFE, buildings which use old and inappropriate glasses cause certain problems for our nature. Next slide, please. And as you can see, the slide shows that in the building stocks, the windows insulation performance is unfortunately not so good. Unfortunately, we do not have a similar study in our country, but what we see that the glass insulation performance, not for the existing buildings, but we have the house stock. And I would like to share, there are 19 million houses. Unfortunately, there is one glass in windows and 50% has double glasses, and only 5% have low E solar insulation glass. And if we have a magical stick, and if we turn all these glasses into low E insulation, then we can save $5 billion, and then we will reduce the greenhouse emissions up to 7,000 tons. So as an individual and also as a citizen and as a member of the whole world who cares about future, what we can do. In fact, it is simple what to do. We can check our windows, and if it is a standard and we need to change our glass, we will save money. And also we can make contributions to the economy in our country, and also we can make a contribution to the climate change issues. So we have been talking about all these values. We have this U value and the G value. You can see the U value if you use one glass. It is 5.8 watt per square meter. And we reduce it to 2.6 by making some arrangements if we have this insulation unit in our windows. That means there is a minor difference if we open it or if we keep it closed. So what we see that 82% enters into the house. That means 22% of the heat lights remains out. So we need to get this optimum value, that is 16 millimeter. And we need to use argon gas. But if we want to be more efficient, we need to have this high-tech solar or low E insulation material. Then G value reduces to 4 to 4 and U value becomes 1.1. Is it possible to have a better one? Yes, why not? We have triple glazed insulation glasses. And it is low E and solar low E plates can be used, and then U value becomes 0.6 and G value becomes 37%. So when we look at the U value, it is 10 times better. So how do we manufacture this low E and solar low E glasses? We manufacture it in a closed circuit, and we have this metal oxide cover bridge. So it is, the thickness is 100 nanometer. It is thinner than your hair. We have been making contributions to nature for 46 years by manufacturing this thermal glasses, and we have manufactured glasses that covers more than 200 million square meters, and we have manufactured 56 million square meters low E and solar low E insulation glass in 25 years, and we have saved 30 million trees by saving 14 billion energy. And of course, it is important for the health and the productivity, and also for hospitals. It is better for the patients, and also for schools. It improves the academic success of our students if we have natural light and if we choose the appropriate material. Of course, we know that greenhouse designing is becoming more and more important every day, and it is also important to get maximum benefit of the glass. In this respect, we have natural light, and also we can control the thermal values, and it is important for safety, security, and also the noise control. Of course, we have this next slide. We, as the flat glass of the Shishe Jam, this is our motto to have we provide consultancy on a project basis, and we work with the project owner from the very beginning, and we have our architects and also engineers, and our team is working on this project from the very beginning to the end, so as to find the most appropriate material, and so as to apply them in the best way and in the most efficient way. So we are talking about of course, projects need to be aesthetic, but in order to achieve this aesthetic aspect, there is need for selecting the right glass and appropriate glass for your project. And if you want to reach us, we have 6 different applications, mobile apps, and then these are available in Turkish and in other languages. And my final point is that I would like to share some examples, some cases with you. For example, it is the project that we have done in Bursa Gaz, and the solar panels and also wind turbines. It generates its energy by solar panel and also wind turbines, but we also have these triple glazed glasses, triple glazed windows, and it is very, very efficient for us, and also it provides the optimum energy, and it combines the sunlight, so staff can have a nice view and also can benefit from the sunlight there. And Istanbul İl Bank, the Bank of Provinces. Last 2 slides. Thanks a lot. Yes. Of course, we don't need to use the same glasses as the Şişecam float glass. We have a very broad product portfolio and catalog, and we can have this type of issues. And we have used different project we have used different products in its north and also south facades. This is our factory. Mersin is a city in the south of Turkey. It is a very hot, it has a very hot climate conditions, and we have our solar power energy, and it is the biggest, one of the biggest solar powers, and it is one of the biggest in all over the world. We have 80,000 square meters, and it generates 6 megawatts energy. And the UN declared International Year of Glass in 2022, and we have worked on this issue very hard in order to produce solutions to this type of issue. Glass is a unique product, and it will be known by the whole world next year. Thanks a lot. You can reach us, mimaricam@şişecam. Yes, thanks a lot for your patience. Thanks a lot, Esra Hanım. It's a very nice and informative presentation. Yes, our last panelist is from Osman Hakan Uslu, and Osman Hakan Uslu will talk about the industrial buildings and passive design concepts and applications in industrial buildings. Let me introduce him first. Osman Hakan Uslu studied Istanbul Technical University, and he studied the engineering of the airspace, aviation engineering, and he has been working in this sector for a long period, and he is working as the research and development and quality manager in his firm. Hello, everyone. Can you see my screen? Yes, we can see it now. And he works for the Assam panel. First of all, I would like to thank Zero Build for providing this opportunity to me and to my firm. And I hope that this forum will be useful for the colleagues who are listening to us now. You kindly introduce myself. Let me say a few words about myself. I have been working in this sector for 25 years in this sector of insulation for 25 years, and I am working as a research and development and quality manager, and I'm working in the firm called Assam Panel. Yes. Assam Panel is an affiliate of Kibar Holding, and we have been working in this sector since 1992, and we are one of the 10 biggest companies in all over the world. And we produce sandwich panels, and it is an insulation material that is extremely important, and it is important for our clients in terms of the efficiency, innovative, and sustainable materials. We have 3 manufacturing facilities. The main facility center is in Istanbul, Tuzla, within our main compound, and we have also facilities in Balıkesir and Iskenderun. And as part of our globalization vision, we have a facility in Jordan and also in Azerbaijan. And the total capacity is 21 million square meter as sandwich panel. The company and our firm is very important for us, and especially the climate change has become more visible in our country, and we feel its impact in our country and different parts of the world. We have these bushfires and also the floods and also the pandemic. These are the key issues and key problems for our health. And such natural disasters indicate the significance of sustainability. Therefore, companies realize that profit-driven approach is not sustainable, and they have to change their approach to the manufacturing process. We as Assam Panel We have several initiatives that are pioneering initiatives in the sustainability. For example, we support 6 UN Sustainable Development Goals, and we will continue to work in line with these 6 in these UN and these SDGs, because 6 of them are at the center of our activities, and we have regulations because these regulations are part of life, and we need to design buildings, passive houses, and other issues. There are some similarities and also differences, because in passive house strategy, you don't have to generate energy, but the energy that you generate needs to be reduced up to 90%. But if it is zero energy, that means it is passive and active. That means zero energy buildings means you need to use renewables, and you need to generate renewable energies. Of course, the amount of energy is important, and the lesser energy that you produce, the lesser energy you will need. And the passive house construction should be taken into consideration. Otherwise, the renewable energy investment will need more. As a result, the passive house structure or the zero energy building, the materials should meet the needs.
Thermal comfort and internal air quality can be ensured with the heating of fresh air, and these passive houses date back to 30 years ago. I wanted to provide a historical background about these houses. The first passive house was built in 1991 in Darmstadt city of Germany, where the concept of passive house was born. The first example actually in our country is Gaziantep ecological building, completed in 2012, almost 10 years ago. Main principles in passive house design includes high thermal insulation, use of thermally insulated windows, waste heat recovery system, prevention of thermal bridges, and air tightness being integrated to the structures. The Passive House Institute provides certification to these houses. As you all know, when we look at the criteria here, the thermal energy requirement of a building should be 15 kilowatts hour per square meter, and the cooling again should be 15 kilowatts hour per square meter on an annual basis. And total fossil fuel consumption should be maximum 120 kilowatts hour per square meter, and the air tightness here should be actually maximum 0.6 air exchange in at 50 pascals pressure, and at values higher than 25 degrees, we should have comfort actually in all living spaces, while the countries should not be more than 10% higher. Actually, we have over 5,000 passive houses and residential units across the world, and 40%, almost half of them, have been certified. And as the graph reveals, Europe has the highest awareness, including Germany and Austria. These two countries account almost for 2/3 of all the passive houses in the world. Mr. Hakan, we can move on to the industrial structures as we are running out of time, as that would be the punchline. Okay. We see passive structures in the industrial field too. Passive house should not just make you think of houses, although that's the general understanding. We have passive house structures in the industrial practices, but they are like limited to 2 out of 1,000 all around the world. And the biggest one was constructed in Europe back in 2008. This is a factory building producing solar panels. The second example is related to a huge factory manufacturing glass windows. Here, there's this 220 millimeter stone wool used in the external structure, including the roof trapezies. And this is the first passive house of South Asia using a sandwich panel with a thickness of 120 millimeters. And just below the insulation panel, there's this actually envelope layer providing airtightness. This is a renovation project, and compared to the earlier version, it provided around 70% air savings. I would like to refer to the positions of panels in industrial buildings. If you think about a building lacking insulation, 42% of the losses result from the roof element. And here we need to use 20 to 30 centimeters of sandwich panels on roofs. Use of sandwich panels actually has a huge impact on meeting passive structure principles through air tightness. When we compare the sandwich panels with traditional wooden facades, we see that they provide 15 times more air tightness, as the metal has superior property. The longer the sandwich panel is, the lower the number of connection units, and actually that minimizes the number of areas with air leakage. To decrease energy losses in sandwich panels, we need to pay attention to 3 points for air tightness. First, the geometry of panel connection points, as they may be connected with each other through different geometries, and these geometries should comply EN 14509, which addresses different types of steel sandwich joints. Therefore, in design, we should try to minimize here the leakages, which has a positive impact. And second, we should make right choice of tightness components. For example, open cell polyurethane foams, when compressed 60 to 80%, provides air tightness. Actually, otherwise we see leakages. And here, closed cells polyethylene foams do not need any compression. They're able to provide air tightness. Therefore, the designers should choose the right component and design the panel accordingly. Polyurethane foam materials are quite rigid composite structures, but there are also stone wool sandwich panels used on roofs. And here, as a fiber characteristic, they are quite flexible. Can you wrap up your presentation, Mr. Hakan? Okay, due to that flexibility, we need to use actually a specific paste between the connection points. As Assan panel, we provide a rich portfolio of products. With stone wool sandwiches, we are able to actually ensure flame retardability for 3 hours, and it has superior flexibility. With polyurethane sandwiches, we can ensure lower heat conductivity at thinner thicknesses, thinner sizes. In addition to our sandwich panels, we have polycarbonate plates for decreasing the light energy requirement of the buildings, as it is also a significant consumption area. In recent times, we had a sandwich panel compatible with residential roof panels And in every roof panel, we know that it is difficult to have a renewable energy panel with photovoltaic characteristics. That's why we had this special design product that comply with the characteristics of photovoltaic panels, and actually they ensure a quality connection despite wind loads. We need to provide them to the markets. Last but not least, our certificates. Assan panel products meet Turkish Standard Institute's criteria. Also, it has CE and GEOS SDR certificates, and their inflammable characteristics are actually certified in FM approved laboratories, as well as European laboratories, and Qatar PVC also are given as certificates, and they prove their compatibility with the green buildings with these certificates. With the regulations, we see zero energy buildings becoming a must, and near zero energy buildings become mandatory for all implementations until December 31st. And Turkey will soon be actually probably enacting near zero building regulation very soon. Thank you for giving me the opportunity once again. Thank you very much, Mr. Hakan. This was a lovely presentation. Of course, after such valuable presentations, we have probably questions, but before taking the questions, I would like to ask a few questions, starting with Ms. Didem, and then I will communicate the other questions by the audience. I'm very curious about this topic because you obtained a very important certificate, a component certificate. So this certificate means that you meet the standards for passive houses, and maybe it will be more affordable to ensure certificates for passive houses. What do you think we can do for these certificates in Turkey? Also, quality actually certificate is important for profiles, window profiles, and you state that in your presentation. What does Deceuninck do, and when do you plan to share those certificates with us? Actually, the component certificate part of your presentation can be shared with us. I know I have asked so many questions at the same time. Let me share my screen as we are running out of time then. Actually, we want many other companies in Turkey to obtain this certificate, but this is also about the market expectation and the markets launched on the products launched on the market. Here we are designing everything right at the design process by verifying the thermal insulation systems. That's an important criterion. I'm referring to the market expectation, but it's an indispensable condition in Europe. And due to differentiated climatic conditions in Turkey, we do not see much of a demand for this certificate in projects. But I believe that after this platform, systems with certificated components will come to the forefront. Let me address your question concerning the cost element. Yes, it has a 25 to 30% price increase in such systems, because in order for you to increase heat insulation, You might have a platform thickness or number of rooms, and they may have an impact on the cost, but after a while, they actually enable you to have a return on your investment. As I stated in energy calculations, I skipped this part. Here you see that UF value is below 1,000, and there are other important advantages in addition to or as concerning the assembly. Structural connections are a criterion for us, but this certificate is also an important factor, and we provide these trainings to our dealerships. Together with Passive House, we're going to see differentiated installation practices, and we think of delivering Passive House related trainings to our dealerships after a while. I don't know whether this will answer all of your questions. Yes, actually, I'm sure there will be more questions concerning this. It is a very nice success, and we are very happy to see you're sharing it. I think before the questions arrive, I can ask Ms. Esra this question. In near zero building, in near zero energy buildings, we talk about triple glasses rather than coated double glasses. What do you think about their usage areas? What can you say about the usage areas? Well, thank you very much for your question, Ms. Shebnem. I also actually did not emphasize this part. When we reach this level, actually, we reach a thermal level like a wall. I mean, rather than sitting behind a wall, you sit before a window and you're able to enjoy the view. So in architecture, our specialists can use these glasses without limiting themselves. Ms. Didem referred to budget-related criteria. I'll do the same. A standard profile and our products with coating can be compared. So when you use a unit with twice coating, the cost will be 30 to 35%, but you are actually building a component which is equal to a whole, but also enjoy the nature and view, although there is such cost increase. Another question for Ms. Aylin. Ms. Aylin, you referred to different solutions on green roofs. I had to interrupt your presentation there. How do those solutions differ, or what should we do based on different preferences? For green roofs, actually, there are many aspects to discuss. This might be a topic by itself, but I wanted to insert greenhouse as a presentation element, although it looks like out of context. Passive house and zero energy buildings, you may have a stone covered or a pebble covered roof, but having it in green form provides a tremendous advantage, both in terms of energy savings and in terms of creating a natural living environment. And with changing climates, we see actually more radical precipitation, and they have been discussing it in the last few years in Europe, that the infrastructure in below cannot withhold such rain, and you cannot change it altogether. Therefore, managing water on surface is actually sought after. So green roofs, let me put it this way, let's say has extensive greening, can withhold 50% of the rain it receives, and you actually give it back to the system by 50%, and the remaining 50% is evacuated with a delay. So giving comfort to your infrastructure. When you look at examples from Europe, like Zurich, which is a small city in Switzerland, actually, this is like 15 minutes away from the airport. You can walk inside the city and complete it in 3 hours. And still, Basel has the highest amount of roof coverage. Why? Because they benefit from every building type. Copenhagen is another example because they had a target of becoming carbon neutral by 2025. So they actually create green areas wherever they are flat. That applies to Zurich as well. Even Chicago is a city of skyscrapers, as you know. They are now having a green roof award program in place. So there's this incentive program in the world. Local administrations say, I will make you discounts in your like contaminated water costs if you have green roof applications. But here you need to determine the usage purposes, whether you're going to be on hang around the roof or not, or whether you're going to have intensive or semi-intensive vegetation. And also, are you building it above a living unit or an underground parking lot? So the systems will vary according to these preferences with different water capacities. And in certain instances, you might even have gray water practice. And in that case, you want to collect irrigation water or rain water. And you may well collect it. You can collect it on the surface and recover it. You can use it again for irrigation, or you can use it for units of the building, like bathrooms. I mean, here we talk about airtightness or wind tightness, but drainage is as much important, because when we say green roof, we talk about preservation and drainage systems. So you may have vegetation on top of a structure, but here, while actually protecting that house, you also create an enjoyable space. I mean, you're creating such a project that your neighbor's roof becomes your garden. Can you think of anything better than that? I mean, 10 years ago, when we have green roofs, they say we're going to have many insects, or they would say, actually, we're going to suffer from the roots of the plants. No, if you choose the right products and have the right practices, then a green roof has a 40-year life cycle. I'm saying it based on the tests. This is according to an institute outcome. Very correct indeed, Ms. Aylin. All these topics are valuable. All these issues are valuable. But I want to ask Mr. Hakan one question as well. You refer to your insulation materials in industrial buildings. In terms of, can you inform us in terms of the use of renewable energy in those industrial buildings? Well, to start with, this is a popular topic. I mean, roof panels are integrated with photovoltaic modules that generate electricity from solar power. And here, the integration can be completed in different ways, regardless of the sandwich structure. However, if you want to have a design with a passive house understanding, and if you want to have, if you did not choose your panel in line with the photovoltaic models, then you have to actually create holes. You can use silicons and seals with to overcome those pores, but that actually damages air tightness. And we have specific products we supply to the market. Here, the carriage indents are specially designed so apparatuses can be actually installed to the photovoltaic cell on one side, as well as the panel on the other side. So photovoltaic cells can be integrated to roof panels without any damage. Here, the design quality matters a lot, because if there is this gap between the photovoltaic panel and the roof panel, so we are going to see this pressure, and that will actually cause the photovoltaic panel to move a little higher. That's why the bearing should be considered in the design process, and all these processes must be tested for better bearing capacity. That will be all from my side. Okay, thank you very much, Mr. Hakan. Last but not least, a question for Ms. Didem. I don't know whether you addressed it already, you answered it already. While as we speak about the component certificates, we can, when are you going to share them with us? No, I skipped that part. You're very right. Can we get information on that? Sure. We obtained the certificate last week, and we had efforts in the background for a long while now, but the project was created in steps. But we have these certificates now, and our sales teams and other marketing companies will be obtaining these documents, so they will be open for use next week. Congratulations once again. Thank you very much. Ms. Esra, before finishing our session, one more question. As a lady, you are having difficulties in the market, in the industry, I believe. We are involved in a difficult industry, and I'm managing a session where women are higher in number. I would like to get your opinions on that as we see such questions. Can I get your opinion? Is it difficult to work in this sector, in this industry as a woman? You have referred to many beautiful activities, so would like to listen to the story from your side. Thank you very much. I believe I'm one of the lucky ones. I have been in the industry for the past 28 years. Construction and architecture seem to be male-dominant industries, but for the past 16 years, I've been serving Şişecam, founded according to the directives of Atatürk. Actually, we have 22% female participation, and I can even say that I benefit from affirmative action as a lady. It is very enjoyable to work as a lady, and here you see we have a majority, and Mr. Hakan's presence adds strength to our power. Thank you very much. We listened to very nice presentations today, and we benefited from your insights as valuable industry representatives. Thank you very much for your participation. I wish you a very enjoyable day. Thank you very much. Have a good day.